AP Statistics students, we're going to move on to section 2.2 by watching a couple of video lessons to help us get through this little bit of a chaotic week. In section 2.2, our purpose is to introduce you to what are known as density curves. That's going to be this first lesson. And in the second lesson, we're going to introduce you to normal distributions. Remember, right now, you know symmetric distributions, uniform distributions, skewed left, and skewed right. So it sounds like we're going to be adding on a new type of distribution, but not really. We're going to explain how distributions are normal distributions are part of the symmetric family when we get to that. What we know and what we want to know. We already know that when you're working with distributions, a list of data, no question about it, you should always provide a graph if they haven't provided a graph for you already. You should always describe the distribution, shape, unusual features, center, and spread. And you should always test for outliers if you have data in a distribution. In section 2.2, we want to add on one more step. When there is a regular, commonly occurring pattern, we can use a simplified model to describe the distribution, and that simplified model is called a density curve. This is very, very simple. I think you'll understand it pretty quick. You know, a lot of times in the real world, even before we go out and collect certain types of data, we come back knowing what the distribution is probably going to look like. And so sometimes we get tired of drawing a histogram or a box plot or a stem plot or a dot plot. Sometimes we don't need to draw one. We just have to draw a representation of what we know it would look like. And that's when we would draw a density curve. Like, for instance, if I roll a die a bunch of times, I would probably get the same number of ones, the same number of twos, the same numbers of threes and fours and fives and sixes. And so every time I roll a die hundreds of times, I just know the bar heights are going to be roughly the same. And so I go, you know what? I don't feel like drawing this histogram. I know what the histogram would look like. It would look like a rectangle, if you will. And this is what's called a uniform density curve. So, in other words, it's a representation of a histogram that has roughly equal bar heights. We just say, I know the histogram would look like this. Now, the important part that you have to understand about all density curves is no matter what shape the density curve is, the area under that curve is 1. And that 1 represents the fact that 100% of the data that was in this histogram is represented by this density curve. This is a skewed left histogram, and this is a skewed left density curve. It's like every time I give an easy quiz, I know that I'm going to get a skewed left histogram. So I get tired of drawing it, and I say, this is what the quiz grade distribution is probably going to look like. Easy quiz. So the density curve takes the place of the histogram, and the area under that curve is 1. This is a histogram that is probably associated with a hard quiz, you know, because the vast majority of people scored low and only a few people did well. So this is a skewed right distribution. Well, in life, when I just know that this particular real life situation usually produces a skewed right histogram, I just say, I know it. This is what this histogram is going to turn out to be. So I draw a density curve to take the place of the graph. And of course, we know that this is a symmetric histogram, and this is a symmetric density curve with an area of 1 underneath. So a density curve is basically just a representation of what we know a histogram or a stem plot or a dot plot would look like in some situations. Okay, hopefully that's okay for you. It's kind of nice. You get to draw a quick curve instead of a whole histogram for a while. Now, when you see a density curve, make sure that you kind of understand this slide. Remember from middle school, the mode is the most frequently occurring number. So in a skewed left distribution, the mode is the highest bar, and the median will be slightly to the side of the mode. Now remember, this is a skewed left distribution. So what that means is that the median would be just slightly to the left of that mode bar. And then we already know that the mean is less than the median from chapter 1 in a skewed left distribution. So you see the mean to the left of the median. If you have a skewed right distribution, then we already know that the mean in a skewed right distribution is greater than the median. And so as we see here, the mode is the highest bar. The median is just ever so slightly to the right of the mode. And then the mean is less than the median. It's being pulled in the direction of that skew. And then the easiest one of all, if a distribution is roughly symmetric, the mean, median, and mode are all roughly equal and centered. So look for questions about that eventually. Now, for the rest of this particular lesson, I want to talk about uniform distributions. My apologies for that changing. So I want to put the skewed and symmetric distributions aside and just talk about uniform distributions for a minute. So remember, a uniform distribution is when the bar heights are roughly the same height, and so the density curve is roughly rectangular. So watch this very contradictory problem. We all know that there's an infinite number of real numbers between 0 and 2. Well, I want to draw a density curve that represents that situation. So I want you to picture 0 is here and 2 is here. And I want you to picture that I come up to some tick mark on the y-axis and I draw a rectangle. In other words, all of the real numbers between 0 and 2, if I randomly picked one, they all have an equal chance of being chosen, so they should occur about the same amount of times. Okay, well remember that the area under any density curve must be 1. And also remember that the area of a rectangle is length times width. Well, since the area under this curve must be 1, well, we see that the length of this rectangle is 2 times some value must equal 1. So in other words, this value must be something that helps 2 times it equal 1. Well, then doesn't that say that the left side and right side of this density curve are both 1/2? Okay, so it's really important that you find the height of the density curve, in this particular instance, to be 1/2. Okay, now, listen to the question now. What percent of real numbers fall between 0.52 and 1.96? So just picture this. Picture this as 0.52 here and 1.96 here. Well, what they're asking me to do is find out what percentage of the entire rectangle is between 0.52 and 0.96. Well, isn't it true that that's just finding the area of that red rectangle? Well, if I come over here and take 1.96 minus 0.52, that would be 1.44. So the distance from here to here is 1.44. Well, this height is still a half. So then, isn't the area shaded in red 1.44 times a half? So that would be 0.72. So 72% of numbers between 1 and 2 are between 0.52 and 1.96. Isn't it ironic that there are an infinite number of numbers between 0 and 2, but I can tell you precisely that there are 72% of those numbers are between 0.52 and 1.96. All right, let's check this next question, and I think that's the last one for this slide. What real number is the 90th percentile in the distribution of real numbers between 0 and 2? So let's see, I'm going to draw the same picture with a height of 1/2 going from 0 to 2. Okay, if somebody says what number between 0 and 2 is the 90th percentile, what that means is what is the number such that the area of that rectangle between 0 and that number is 0.90. So let's see, we need the length times the width to be equal to 0.90. So let's see, that's going to be x times a half equals 0.90. X equals 0.90 times 2, which is 1.8. So we say 1.8 is the 90th percentile. All right, so that's the first lesson, and I will assign homework problems, page 138, 41 through 43. Ignore the last page of the slides, do these three.